Okay, here is the 9 test review answers going through the test review here. So it says find a positive and a negative coterminal angle. So remember that we can add 360 or subtract 360 to end up in the same spot. And that's what coterminal means, lands in the same spot. So with this one, to find a positive, honestly, if we take and subtract 360, it's still going to come out to be positive. So that is actually equal to 345. That's a positive coterminal angle since it's positive. And if we subtract 360 again, we'll get our negative coterminal angle, which happens to be negative 15 degrees. There's positive and negative coterminal angles. These will fall in the exact same spot as 705 degrees. If you were to draw all of these, they'd land in the same spot. They'd land right here. Okay, so find a negative and positive coterminal angle. So if I subtract 360 on this one, once again, it comes out to be positive 75 degrees. So there's a positive coterminal angle. And if I subtract 360 again, I get negative 285 degrees. There's our negative coterminal angle. So it says find a coterminal angle between 0 to 360. So you have to either add 360 or subtract 360. You just need to get on that interval between 0 and 360 degrees. So with this one, I'm going to subtract 360 because I see that that's going to be 10 degrees. Now that is obviously between 0 to 360 degrees on that interval. So we are good to go. All right here, I see I need to go lower because it's 360. So I'm going to subtract 360 again. So that is 104 degrees, which is obviously on the interval from 0 to 360 degrees. So we're good to go. Okay, so it says find the measure of each side indicated round to the nearest tenth. What I want you to notice is this is a right triangle, This is right triangle trig. Good old-fashioned sine, cosine, or tangent. So if you remember you're saying, oh heck, another hour of agony, then because they're right triangles, you're going to use a right triangle trig. Not unit circle trig. Oops, and not, sorry, I can't multitask, right, and talk. You're not going to be using unit circle trig, and you're not going to be using the law of sines and cosines if it's a right triangle. Oh heck, another hour of agony. So here we go. Let's see which one we're using in this particular case. So there's my theta. My adjacent and my hypotenuse are what I know. Adjacent and hypotenuse would be cosine. So let's set up a true statement. Cosine of theta is adjacent over hypotenuse. So we have cosine of 57.5 is equal to my adjacent's x, my hypotenuse is 13. Then all we have to do is solve for x. So get x alone. So in this particular problem, we'll multiply both sides by 13. Now notice x is all by itself, so you'll type that into your calculator. Make sure it's in degree mode. Since this is a degree, you're inputting right here. So if it's in degree mode and you type this into your calculator, you should get x is equal to 6.98. That's a side length. Okay, moving on to this one. Let's see what our true statement is. There's theta, opposite hypotenuse. Oh, that one's going to be sine. So plug in everything you know. So in this one, we have sine of 20. Our opposite is x. Our hypotenuse is 15. Now the algebra in this one happens to work out. I don't love that it happens to work out the same way as the last one. We just multiply both sides by 15. So then x is alone. You'll type that into your calculator, and you would get x is equal to 5.13. Just remember, though, if we would have had this instead as a true statement, if we would have had 15 over x, we would have, if that was the case, which it wasn't, but if it was, we would multiply both sides by x. And then after that, we would divide by sine of 20. So just remember that the algebra can come out a little differently depending on the problem. Okay, it says find the measure of the angle indicated. Once again, notice it's a right triangle, So we must be using the 3 right triangle trig ratios. Just keeping that in mind, because people, when they have all of the knowledge of unit circle trig, right triangle trig, and then law of sines and cosines, they kind of tend to forget when to use what. The right triangles are obviously going to be right triangle trig. Here we go. So let's set up a true statement. From theta, we have adjacent and hypotenuse. That must be cosine. So you'd say cosine of angle theta is equal to adjacent is 6, hypotenuse is 11. Because we're trying to get theta alone, we would then have to get cosine to be undone. So we would cosine inverse both sides of the equation. So our theta is going to be cosine inverse of 6 over 11. Make sure, because we're finding a degree measure, that you have your calculator in degree mode. Therefore, theta is, then you would type in inverse and you would get 56.9 degrees. All right, let's add this one. Opposite adjacent. That one must be tangent. So our opposites 7, our adjacents 11. And then once again, because we're trying to get theta alone and it's trapped inside tangent, we would have to, in this problem, tangent inverse both sides. So theta is equal to tangent inverse of 7 over 11. You type it into your calculator and you get 32.5 degrees. Okay, it says find the value of the trig function indicated. We're still dealing with right triangle trig. So sine is, oh heck, with right triangle trig, that is true. With unit circle trig, sine is the y value. However, right triangle trig, sine is opposite over hypotenuse. So it says find sine. Well, notice we don't have the opposite. So we have to push pause. We have to hurry and do Pythagorean theorem correctly, find that other side, and then we can answer the question. So I first push pause, and we're going to set up a Pythagorean theorem statement. Let's hurry and find this. So we would say 16 squared plus x squared equals 20 squared. Then to get x alone, we would subtract 16 squared from both sides. So then we would have 20 squared minus 16 squared. Now when you type that into your calculator, this and this, you would get x squared equals 144. So then you would square root both sides. Therefore, x is equal to technically plus and minus 12. However, it would not make sense to have a negative side length, so we throw out the negative. So that is 12. All right, now that we know that that's 12, we can answer the question. Sine is opposite over hypotenuse, so 12 over 16. But then you would take that answer and simplify it. If you want, you can type into your calculator 12 divided by 16, hit math, enter, enter. If you do that, then you would get 3 divided by 5. Or you could just see they both divide by 4. However, I do recommend the calculator option just because you won't get it wrong for sure. Okay, find tangent. Tangent is opposite over adjacent. We don't know our opposite side, so we're going to have to push pause on that and come back. So our true statement is 12 squared plus question mark squared equals the hypotenuse squared. Remember, put the hypotenuse out here always. So we'll subtract 12 squared over, so we'd have question mark squared is equal to 15 squared minus 12 squared. Now, if you do that in your calculator, you have question mark squared equals 81. Now, in this particular problems, all of these square roots have come out to be perfect square roots. However, remember, if we would have got the square root of, I don't know, like, let's see, like 80, then with that being the case, you'd have to break it down and pull out groups of 2 and simplify it that way, not put a decimal. But these have all come out to be perfect square roots, perfect answers, so we've been good to go so far. But just keep that in mind, because that is not always true. We've just kind of lucked out and had some easy problems here. So now tangent is opposite over adjacent, so my answer is 9 over 12, which simplifies. They both divide by 3, so this becomes 3/4. Or once again, you could type into your calculator 9 divided by 12, math, enter, enter. Okay, these ones tend to be harder for people, so just take my suggestion. You need to draw your own triangle. Go in the order that I'm about to suggest. It says, find tangent of theta, given that cosine of theta is this. Now, this is right triangle trig, so you'd say cosine is adjacent and hypotenuse. So the first thing you do is go off to the side, you would draw a right triangle. Make sure you put in theta before you put the sides in, because otherwise you might put theta in the wrong place. So I'm just going to put theta right here, and now I'm going to draw my picture true according to theta. My adjacent side, boom, is here, and we were told that that's 2 root 13. My hypotenuse is here, therefore this is 13. Now it says find tangent, so I'm going to need this opposite side. So I'm going to have to push pause, come back to that later, after I go through and find this side. So my true statement, use parentheses. 2 and root 13 are squared plus question mark squared is equal to 13 squared. So remember right here, you're going to have to square both of these things. So that would be 4 times 13. And then we have, so 4 and 13. And then plus question mark squared equals 13 squared. So then let's calculate this out here. 4 times 13 is 52. And then over here we have 13 squared, which is 169. So now we'll be taking and subtracting 52. We have question mark squared equals, I believe, 117. Then we'll square root. Notice if you did that, it would be a decimal. We're not allowed to do decimals. So the next thing we would check is, does the square root of 117 break down. We would try a bunch of different factors, try breaking it down, keep going, but nothing works, so it doesn't break down. So that means you would leave the answer as the square root of 17. You would never do a decimal. Root of 117, so 117. Did not break down, so we're going to leave it. So now tangent is opposite over adjacent. Oh, wait. 117 does break down. So we need to go back, push pause on that, and let's simplify the square root of 117. So let's break this bad boy down. 117 looks like it breaks down into 9 times 13. 9 breaks down into 3 times 3. So we're actually going to have 3 root 13. My bad. So it's a good thing to not give up too soon, otherwise you might mess up. So this is actually 3 root 13. So when I was going through, I should have divided 117 as many times until I found something. There are times though when it doesn't break down, but just make sure you don't give up too soon. Okay. So continuing, tangent is opposite. 3 root 13 over adjacent, which is 2 root 13. Now, if you're smart, you're going to notice right away that we have a root 13 and a root 13. Anything divided by itself is 1, so those cancel out. So 3 over 2 is our final answer. All right, find sine of theta. Given tangent of theta is that. So that's opposite, that's our adjacent. Draw your right triangle, put your theta in. Our opposite side is 3 root 7. Our adjacent side is 7. Therefore, we've got to go through and find the hypotenuse. So we would be doing 7 squared plus parentheses, because there's two things. 3 root 7 squared equals the hypotenuse squared. So then you would have 49 plus, right here, square both of those. So that would be 9 times 7, which is 63. And then when you add those up, you get 112 is equal to question mark squared. You'd square root it. If you do it in your calculator, you get a decimal. We've got to break it down by hand. So we actually get 4, oh, that's not true. Let's see what we actually get. Well, it is true, but I'm going to do something. Let's see. I'm breaking this down. It looks like I have 16 times 7. 16 breaks down into 4 times 4. So I actually get 4 root 7, looks like. Our hypotenuse is 4 root 7. And now we can answer the question. Sine is opposite, oh heck, opposite over hypotenuse. So our answer is 3 root 7 over 4 root 7. And notice in this particular problem, these cancel out. So therefore, my final answer is 3 over 4. So I didn't even have to rationalize my denominator because it simplified first and there was no radical in the denominator anymore. However, just a reminder on the test, if you were to get something like this as your final answer, 2 over root 3, you would then rationalize your denominator. You would multiply by root 3, so you'd get 2 root 3 over the square root of 9, which is 3. Just a reminder how to rationalize. Convert from radians degrees to degrees to radians. So we multiply by 180 over pi, because we put pi on bottom because we need our pi's to divide out. Then you would take your calculator, 7 times 180 divided by 6, and that would be 210 degrees. All right, taking this degree to a radian, you'd say I need to put the degree on bottom because I need my degrees to cancel out. So now you would take your calculator. Do not type pi. Did you all hear that? Do not type pi into your calculator. Only type in 255 divided by 180, hit math, enter, enter. If you do, you will get 17 over 12, so you actually had 17 pi 12. I just want the exact answer for that. That's the radian, the pi radian. So converting this, we would put 180 on top, pi on bottom, because we need our pi's to divide out. So you have negative 180 divided by 2, which is negative 90 degrees. We just converted that to the degree measure. So right here, we'd multiply by pi over 180. And once again, do not type pi into your calculator. Just type in 40 divided by 180. Math, enter, enter. You get 2 ninths. So this came out to be 2 pi ninths, and that's the radian. All right, it says find the exact value. Anytime you see the word exact, that means you are using unit circle trig. In fact, if you're ever asked to find sine, cosine, tangent, you're not dealing with triangles, and it's a measure on the unit circle. You need to be finding exact answers only. Calculators not allowed. So you will have a unit circle, a blank one you will have filled out for the test. You will be able to then refer to it for your answers. So it says find sine of this angle. So basically, guys, this is saying find sine of 90 degrees. Same exact thing. It's just it showed a picture and then it said sine. So we would go to 90 degrees, which is right here. And then we'd say sine is the y value if it's on the unit circle, x, y. So my answer is equal to 1. Find the tangent of 150 degrees. This is on the unit circle. You would locate 150 degrees. You will have to remember that on the unit circle, tangent is y. So let's see, tangent is y divided by x. The y value here is 1/2 divided by the x value, which is negative root 3 over 2. So you'd say dividing fractions is easy as pie. We flip the second fraction. So this one gets flipped. 2 goes on top, root 3 goes on bottom, and multiply. Now I want you to notice something else. Our 2's are going to divide out in this particular problem. So right now I now have 1 over the negative root 3. So I'm just going to put the negative in front. You'd say that's my answer. I've just got to rationalize my denominator because that answer is not considered simplified. So now I rationalize by multiplying by root 3 over root 3. So my answer is negative root 3 over the square root of 9, which is 3. There's tangent at 150 degrees. Tangent at 150 degrees is negative root 3 over 3. Sine at 90 was 1. So this is just the same thing as saying find the tangent at 150 degrees. Okay, find the cosine at 4 pi thirds. You would locate 4 pi thirds. Cosine is the x value if it's on the unit circle. So my answer is equal to negative 1/2. It's easy enough. Find the cosine of 5 pi thirds. So you would find, that's, you guys, this is the same thing as saying this. It's just they're showing a picture. Find the cosine of 5 pi thirds. That is the same thing as this. It says find the cosine of 5 pi thirds. So I locate 5 pi thirds, cosine's the x value, so my answer is 1/2. Cosine's x, sine is y, tangent is y over x. Now you will want to remember secant is the reciprocal of cosine. So here the secant would be 2 over 1, which is 2. The cosecant is the reciprocal of sine. So if sine was, I don't know, this, then cosecant would be just flip those fractions. And then you would have to rationalize your denominator in a lot of cases, but I know you can do it. And then remember that cotangent would just be the reciprocal of tangent. So right here, back, let me just go back one. The cotangent, you would find the tangent, which was, we just said, this was the tangent. So if I asked you to find the cotangent, you would reciprocate it. You'd say, okay, this is my answer. And then you would rationalize your denominator. You'd do root 3. We would have 3 root 3 over 3, a negative in front. Now notice my 3's would divide out, so negative root 3. That would be the cotangent. Okay, it says find the length of the arc. I'm only going to do 21 because they're all the exact same. Now remember, the length of the arc is radius times theta, where theta has to be in radians. Check, and if it's not in radians, then you would change it to radians by multiplying by pi over 180, just like we did a second ago. However, if it's already in radians, such as on the review, you are good to go. It's really easy. You take your radius, 6 inches, you times it by 3 pi fourths. I want the exact answer. So that means you would not type pi in. You'll do 18 pi over 4. Then simplify your fractions, not with pi, but do 18 divided by 4. I will be marking off if you do not put the prettiest exact answer. Oh, 6 times 3, yeah, it is 18, we're good. So then that is 19 pi half inches. That is one of the answers. Then length of the arc, the physical length, is probably best written as a decimal as well. So I would write down the pretty answer, the mathematical answer, and now the engineer answer. Now you will type pi into your calculator. So now you do that, and there is your answer. And 22 through 24 are the exact same process. Okay, now we're getting to the stuff towards the end of the unit. It's to find the area of each triangle. Notice this is a non-right triangle, therefore you have to use the formula. Area is equal to 1/2 times side 1 times side 2 times the sine of the angle in between those two sides. So this is easy enough because notice I have an angle, a side, therefore I can just go right for the formula. We have a 1/2, our first side is, I don't know, 12, order doesn't matter, our second side is 4, and then times by sine of the angle in between. So now make sure your calculator's in degree mode. Since you're inputting a degree, you would type it into your calculator here, and you get 18.11, and that would be square meters. Remember, that doesn't affect anything. That was just a meter times a meter, that's why it's square meters. Okay, this one is law of sines and cosines. Now, I'm not saying, notice in the instructions, I did not tell you you needed to use law of sines or cosines. You have to decide that. So a couple of things I want you to recognize. This is not a right triangle. Therefore, you cannot use sine, cosine, tangent. You cannot use the Pythagorean theorem. That only works for right triangles. There's nothing in here saying we have a right triangle. Therefore, we are using the law of sines and cosines to find missing angles and missing sides. This says find AC. I highly recommend putting an X there and just setting up your equation accordingly. Now remember, the first thing we try is to use the law of sines. If we cannot use the law of sines, we will then opt for the law of cosines. So let's see, the law of sines here. Now it's sine of the angle divided by the side across from it will equal the sine of the angle divided by the side across from it. And you can flip this. So notice we're trying to find a side length x. So I'm going to put x on top. That's a side length. Now the side across from that is this. You've got to stay consistent. So we have sine of 39 degrees. That's equal to side length. This is the only side length, so I've got to use that, divided by sine of the angle across from it. Now some of you are going to say, oh no, Miss Christensen, I don't have this angle. But remember, if you have all three angles of a triangle, or all two angles of a triangle, all three angles of a triangle added to be 180. Therefore, you can do 180 minus 57 minus 39 and get that this is 84 degrees. So now I have enough information. So sine of the angle across from side 19 is sine of 84 degrees. And then you'd say, each problem is different, but in this problem, I have to solve for x, so I have to get x alone using algebra. So we would multiply both sides by sine of 39. So then from there, they divide out. Therefore, x is equal to 19 sine of 39 divided by sine of 84. You would type it into your calculator, once again, making sure it's in degree mode, since these are degrees. And you would get x is equal to 12.02. Okay, it says find the measure of angle C. Let's put an x here, and let's see if we can set up the law of sines. If not, we'll go for cosines. So here we go. We would have to say, I'm trying to find x, but that's an angle, so that's going to be trapped inside sine. So sine of angle x, all over the side across from it, is equal to sine of, we do have another angle, 122. The hope is that we have the side across from it. If we do, we can set up the law of sines. And look at that, we do have the side across from it. So now we're good to go. Solve for x. So in this problem, to get x alone, the first thing you would do is multiply both sides by 31. So now my true statement is this. Sine of x is equal to 31 sine of 122 all over 56. And now in this particular problem, because we need to get x alone and it's trapped inside sine, we would take the sine inverse of both sides of the equation. So we have x is equal to sine inverse of all that stuff. And then you would type it into your calculator just like that. And you would get the angle of angle C. Angle C is equivalent to 27.99 degrees. So there you go. Find AB. All right, let's set an X here. Once again, let's try to set up the law of sines here. So it's a side length, so X over sine of the angle across from it, 42.2, is equal to a side length. I could use this side length or this side length, but unfortunately, I don't know either of those angles, so I cannot continue with the law of sines. So now we're going to say, okay, law of cosines here. Now remember, if we're trying to find a side length, that's what goes on the outside of our law of cosines equation. So we're going to have x squared is equal to side 1 squared, 7.4 squared, plus side 2 squared. So 17.5 squared minus 2 times 7.4 times 17.5 times by cosine of the angle across from the missing side. Let's see what that is. Oh, 42.2. 42.2. It's kind of jammed in there, but it is 42.2. Now you say, I'm trying to get x alone in this particular problem. All I have to do is square root both sides. Now type it into your calculator very carefully. Type it in. And then if you do type it in and you set this up correctly, which we have, we will get, this is a side length, 13.005. How is that side length? All right, next one, here we go. It says find angle C. If I put an x here and I try to set up the law of sine, sine of x over the side across from it, 7.9, is equal to sine of, well, we don't have any other angles, so we cannot continue with the law of sine. So now this is angle C. So the side, this is what's really important. We have to use the law of cosines, and you have to have the outsides match up for your law of cosines, if you remember me talking about that. If not, go back and rewatch the video. It would be, I guess, 9-4. So law of sines and cosines. But remember, the side across from the missing angle is what has to be on the outside. That's really important, everybody. So there's the side squared equals one of the sides squared plus the other side squared minus 2 times that times by cosine of the angle in between. So now in this one, to solve for x, it's going to take a little bit more careful algebra. You could literally go through and calculate each piece here. So if you did 7.9 squared, you get 62.41. That's equal to, and if you do these two added up, we can add those up. So, or really how we did it in class is we kind of just said, okay, let's subtract. So our algebra was easier. Let's subtract 6.9 squared. 6.9 squared, and let's subtract 8.4 squared to both sides, and subtract 8.4 squared. So now you type in your calculator, 7.9 squared minus 6.9 squared minus 8.4 squared, which this minus this minus this, these are gone now, that's equal to negative 55.76. So then that's equal to, all this stuff is being multiplied. So remember right now I have this, negative 2, 6.9, 8.4 cosine of x. You cannot add those over. This is multiplication. The only thing that undoes multiplication is division. To make this an easier division problem, I recommend actually multiplying those together. So we have negative 55.76 is equal to, when I multiply those together, I get negative 115.92, then cosine of x. So then we'll divide both sides by negative 115.92. So now what we have here is this divided by this. We could write in the negatives, but a lot of people will say, oh, well, won't two negatives divide out? Yeah, they will. So you don't even have to write both the negatives. And that's equal to cosine of x. Now, because x is trapped inside cosine, at this point, you would then cosine inverse both sides. So now look, cosine inverse undoes cosine, x is alone. So you would type in cosine inverse of all that stuff. And you would get x is equal to 61.2 degrees. Once again, if you have a hard time with the law of sines and cosines, please go back and rewatch the video on that. Last one of the review is the story problem. Guys, the story problem is obviously going to be something you've learned. It's either right triangle trig, it's either law of sines and cosines for non-right triangle trig. So let's look at this problem. It says, if you read it, a forest ranger in an observation tower sights a fire 37 degrees east of north. So they've already drawn the picture. That must be here. Then it says, a ranger in a tower 20 miles due east of the first tower sets the fire at a 43 degrees west of north. How far is the first fire from the first tower? So we're looking at the distance from here to here, this distance. Now notice we only have angles on the outside of the triangle. We need to go and find that angle and then find this angle here. So we can do that by recognizing, and it is kind of, I mean, honestly, you can't usually assume this, but there really isn't tons of information here. But we're going to say that this is 90 degrees and this is 90 degrees. So to find this angle, you'll take 90 minus 37 and you get a 53 degree angle here. 90 minus 43 and you get a 47 degree angle. So now we have this triangle, everybody. Look, we have a 53 degrees. We have a 47 degrees. We have a 20 and then my x is right here. So now look at it. It's just a triangle. It's not a right triangle. There was no right angles in the triangle. Inside the triangle, there was no right angles. But we can now find this angle, and then we can set up the law of sines to find this side. So we would do 180 minus 53 minus 47. Therefore, this is 80 degrees. Now to find x over sine of the angle across from it will be equal to 20 over sine of the angle across from 20, which is sine of 80. And now to solve for x, we would just multiply up by sine of 47, because it would divide out over here. We love algebra, and it was a really basic problem because law of sines is not hard. So don't, guys, you got to be able to think a little bit. You've got this. Come ready for this test. Re-go watch any videos you might need. Know your unit circle. Know your formulas. You have to know those by heart. Know how to convert. Know your right triangle trig. You're going to do awesome.